Hello there and welcome. My name is Michael Fudge. This is lesson 5 in our Learning to Program in Java series. In this lesson, we'll learn to create our own methods. In the last lesson, if you remember, we learned about objects and classes. Objects consist of state and behavior. The state was represented as properties and the behaviors were represented through methods. Now when you go to build your own class, you are going to have to create your own methods to define the behaviors of the objects that are created from that class. So this is the next logical lesson in the steps as we learn about objects and classes. First we'll define what a method is. Then we'll look at the anatomy or the breakdown of a method in Java. Then we'll look at the breakdown or anatomy of the typical Java method. Then we'll dive into an example where we calculate the area and perimeter of a rectangle. Then after that, we'll talk a little bit about variable scope and lifetime and how variables are sent in and out of methods through the parameter list. First, what is a method? A method is nothing more than a section of code. The code that we write in the method can be reused, so we can write it once and run it as many times as we want. When you run a method, it's called a call. In Java, methods are part of classes, so you cannot create a method unless it's a member of a class. And static methods can be called without declaring the object of the class first. And you've seen this in examples when we use system.out.print, for example. So let's talk about the pieces and parts of a typical Java method. The method you're looking at right here is defined as square, and it takes in a number of type integer. And then it does some work and returns a result. The word public is what's called the access modifier of the method. Usually methods are either public or private. Public methods of a class are accessible through the object. Private methods of a class are only available inside the class itself. Static is a declaration. You can either include static or not. When you include static in your method, what you're saying is you can use the method without declaring an object of the class. If you leave static off, you're saying in order to use that method, you must first define an object and then access the method from the object using the dot operator or the period operator. This is the data type that the method returns. The data type that is returned by the method is always next to the name of the method, which is right here. So the name of the method is square and it returns an int. In the parentheses after the name of the method, we put one or more parameters. These parameters look like variable declarations, but actually what they are is a contract. It's a promise. You're saying that in order to satisfy the method square, you have to give it an integer. I'm going to give that integer an arbitrary name called number. Then we have your usual beginning and ending braces that mark the block that creates the body of the method. Inside the beginning and ending brace is all the code necessary to satisfy the logic associated with the method name. You can see inside this method I'm using number in the first line of code. That number is not necessarily a variable, but it's a parameter that comes into the method. When you go to call or access the method, you're going to give it a value, and that's the value that's going to get replaced with the word number when the method runs. Every method that has a return type needs a return statement, and the return statement is usually the last statement in the method. You can see in my method here I'm returning the variable result. Okay, let's take a look at our first demo. In this first demo, we will write a program that calculates the area and perimeter of a rectangle, but we will write two methods, one called rectangle area and the other one called rectangle perimeter, and those methods are going to be the mechanism by which we calculate the area and the perimeter of that rectangle. Let's get started. Well, here I am in the NetBeans IDE, and I've created a new project called Method Basics, which will take us through the basics of how to create the two methods that we described to calculate the area and perimeter of a rectangle. And if you notice right now, my cursor is blinking on line 7 inside a method. That method, the name of that method is main. It returns void, which means it returns nothing. It's a static method, which means I do not need to declare an object of the class method basics in order to use this method. And it's public, which means it's accessible outside of the class name method basics. this main method is the entry point for which the program runs, as we've seen before. Outside of this method, I'm going to collapse the method down. Outside of this method, I'm going to write another method, public static int rectangle area. And my method is going to take two parameters. It's going to take an integer for length and another integer for width. And I'm just going to give them the arbitrary names sum length, sum width. I need to declare this method as static because it's inside the main class here, method basics, and I want to be able to use it without declaring an object from the class method basics. It's redlining here because I am not returning a value. Anytime you have a return type, you need to return a value, so that's why it's complaining. I'll get there. All right, so let's write some code to do this. I'm simply going to return sum length times sum width. Likewise, let me write a method that does perimeter. And this method here will return the perimeter, which would be 2 times the length plus the width. It should be noted that the words sum length and sum width are completely arbitrary. I don't have to use this. I could just say x and y here, and then just replace this with x and y here. However, you want to make sure that you name your method parameters in a meaningful way so that the caller or the user of your method understands what your expectations are. So that's why I chose to use sum length and sum width. What I'm trying to tell the person that's going to use this function is that you need to give me some arbitrary length and some arbitrary width as integers. Oh, I spelled perimeter wrong. Okay, let's go back up to our main method now, and let's write some code to try out our function. So I could do something like this. In the very simplest example, I could say system out println rectangle area, and I need to give it some length, how's 5, and some width. Let's run that. And I get 50, right? Because the area of a rectangle with width 5, length 5, and width 10 would be 50. I wrote this method once, rectangle area, but I can run it many times. So, and then I can change the arguments that I pass in. So the first rectangle area is 50, the second one is 42, and the third is 3. It should be noted that when you define the method, these things that you pass in are called parameters, but when you run the method, the things you pass in are called arguments. Arguments are always real values, so they're either what's inside of a variable or a constant value that satisfies the data type that the method is requiring as part of its contract. One thing to note is my program doesn't have any syntax errors, but I could have made semantic errors. Like, for example, what if I said the rectangle's area is sum length plus sum width? That wouldn't be right. That's not the proper formula for the area of a rectangle. This gives me a chance to talk about a concept that we'll cover in a couple of lessons called unit testing, where you find a way to write code to verify that the method that you wrote is indeed working correctly. That is, it does not have any semantic errors in it. For now, let's just write it the correct way and assume that it has no bugs. And let's erase out the main method body and write a full program to use these two methods. So let's start out with a variable. And let's pull in our scanner class. And then I'll hit Control-Shift-I to fix my import. Now let's get some input here. And we'll repeat this for width. Now that I have my length and my width, I could calculate my area and perimeter. Let's do it this way. Int area length width. There's a call to my rectangle area method. And then the return value of this method I will store in the variable area. And then let's do perimeter. Now let's print out our area and perimeter. And let's pass in our two arguments. The first %d should be the area, and the second %d should be the perimeter. So area per. That's the whole program. Let's see if it works. Enter the length, 5. Enter the width, 6. Area 30, perimeter 22. Does that make sense? So 6 plus 5 is 11, times 2 is 22. Yep, 6 times 5 is 30. Looks like I did it right. Well, that was our brief introduction to methods in Java, but now we need to kind of take a step back and answer a really important question. What is really happening here? What we want to do is understand exactly what this is doing and how it is doing it. Knowing this will make you a much better programmer than just kind of forming your own model of how it works. Let's do an example. As you can see, I've started a new project. The name of this project is Variable Scope. And I've created a function or method, if you will, called SayHello, which is a member of the Variable Scope class. And because it's static, I will not need to create an object of type variable scope to use it, and it takes one parameter name. So let's call this function, give it an argument, and see what happens. You can see what it's going to do is it's going to print hello person's name. Let's try it out. So if all things work as expected, this should say hello Mike and then hello Dave on the next line. Let's give it a run. Hello Mike, hello Dave. Looks good. Now, let me see if I can kind of throw you through a loop here. What if I said string name is Mike? And then I pass into the hello method the argument name. This should still say hello Mike and hello Dave, right? And it does. What if I were to go below system out printf here on line 12 and add a line that says name is Tony? And then rather than print Dave, I'm going to print name once and then name twice. So first of all, name is Mike. Then I say hello Mike. Then I go down here. This will print out hello Mike. Then it's going to change the name to Tony. Then it's going to go back up here and say hello again. Then it's going to go down here. The question is, the second time, is it going to print Tony or is it going to print Mike? Well, let's run it and find out what happens. It says hello Mike twice. So you might be saying, well, if it has a name, if it's name here and it's name there, how can it not be the same name? They have the same variable name. And this is the first real important lesson you want to understand, is that when you define a variable, the variable only lives within its block. So you can see this block here. This variable only exists within this block. When I call say hello and I pass in name, I'm not passing in the variable name. I'm passing in the value of the variable name. So when I say hello name, I'm really saying the same thing as saying say hello Mike, because that's the value of name. So then when I get down here, name has the value Mike, and then this printf uses Mike, and then I change that value to Tony. But then because this variable here only exists within this block, by the time I reach this statement, which returns me back up here into this method, this version of name no longer exists. One way you can really see this happen is if I put a breakpoint on line 14, the line of code that closes the block of the say hello method. Then what I'm going to do is I'm going to step through this code a line at a time so you can watch what happens. So I'm going to hit F7 to start the code, and then F8 to step through it a line at a time. F7 to start. Right now there's no name variable, but after I execute line 6 there will be. F8. Now name gets the value Mike. When I call this method, it's going to come down in here, and then it's going to stop on this line here at the breakpoint. Watch what the value of name is when I get down there. Name is Tony. Let's push F8. Now name is back to Mike. It's not the same name. Every time you create a method, the block inside the method can have variables of the same name as another block, because they're just arbitrary values, and they only exist within the begin and end braces of the block. I'm going to modify this code, and I'm going to ask you to take a guess what it's going to do. So imagine if I put this back to name, and then place name Bill down here, and then get rid of Tony here, and let's remove our breakpoint. Now, what do you think this program is going to do? Let's see. It's going to set name to Mike. It's going to say hello Mike. It's going to set name to Bill. It's going to say hello to Bill, right? And you would be absolutely correct if you said that. Now, what if I go down here and set name to George? What is this program going to do? Is it going to say hello Mike, hello Bill? Or is it going to say hello George, hello George? Let's take a run. It says hello George, hello George. And what is happening here is you're passing in the value Mike into say hello, and then it comes down here and says, I'm going to make a variable called name that's going to exist from here to here. And it's going to have the value to start out Mike, and then I'm going to set that value to George, and then I'm going to say hello George. Then when I go here, name dies, I come back up here, but in this block a different copy of name still exists. That name I'm going to set to Bill. Then I'm going to call say hello again with Bill. I'm going to come down here, string name is Bill, then I'm going to set it to George, then I'm going to print hello George, then this version of name dies and I come back up here. So hopefully what you've seen here is that these values that you have in your parameter list are arbitrary, and they only exist within the scope of the function itself, which starts with the curly brace and ends with the ending curly brace. And the fact that this has the same variable name as another variable in another method has no bearing on anything, because these variables only live within the context of the block in which they were defined. That concludes our 5th lesson on learning to program in Java, where we looked at how to create methods and how to call methods, and we talked a little bit about variable scope and lifetime within methods. Next week, we'll learn to create our own classes. See you then. Thank you very much, and as usual, if you have questions, comments, or feedback, post them onto YouTube. Goodbye now.